Welcome everyone. The question that is shown on the screen, it is the question number 15, assertion, reason type of question of CBSE sample paper 2025. Assertion is nuclei having mass number about 60 are least stable. Reason is when two or more light nuclei are combined into a heavier nucleus, then binding energy per nucleon will decreases. Okay. So this thing is basically explained by one particular graph, we can say. Let me draw this. So in the y-axis, the binding energy per nucleon is plotted. In the x-axis, mass number is plotted. Okay, and how the graph looks like? The graph is talking about the nuclear stability. When the value of A is around 56, okay, when the value of A is around 56, that is iron, at that time the value of binding energy per nucleon is of the order of 8 mega electron volt. Okay. So in that particular case, the energy is basically increases, binding nucleon increases like this way, and then it decreases like this way, and it has a peak at A equal to 56 around iron. So most of the elements our in our earth is basically iron compound or metallic iron, that is the stable one, we can say here. So nuclei having mass number about 60 or least stable, we can say. Nuclei having the mass number about 56 or 60 are the most of the stable, because the binding energy per nucleon, which basically reflects the, we can say, the nuclear stability, it is more. That means actually in nucleus, neutrons are there, protons are there, all are nucleons, little bit different in mass number, all are resides in a very small positions, and where we can say that is a nucleus. Okay, here the Coulomb's law is not applicable. Okay, but they are keeping in a very small place due to this nuclear force. And when the binding energy per nucleon will be greater, the nucleus will be very strong and very stable. When two or more light nuclei are combined into a heavier nuclei, then the binding energy per nucleon will decrease. Obviously no. Obviously no. Because here if I say it is for helium, it is for helium, it is for neon, okay, it is for argon, like this. Okay, it is for argon. Okay, so when two or more light nuclei are combining, we can say nuclear fusion, just like 1 H1 plus 1 H1, when at a temperature 10 to the power 7 Kelvin just fused with each other, at that time we are getting that helium nucleus. We are getting helium nucleus. Okay, or if I say 2H1, that will be better understanding. Obviously after that some result in as another particle and energy that is evolved. So when two or more light nuclei are combining, that is which is called a nuclear fusion, heavier nucleus is formed, then the binding energy per nucleon will not decrease, it will increases. But if you say the higher order nuclei, just like we can say uranium, polonium, which are very heavy, if they just divided into its fragments, then what will happen? Its energy, its binding energy per nucleon decreases according to this formula. This is the experimentally obtained data which is plotted that, and that explains the nuclear fusion of the lighter nuclei and nuclear fission of the heavier nuclei. So here the assertion what is said, the nuclei having mass number about 60 are least stable, completely wrong, they are stable nucleus. When two or more nuclei are combined into a heavier nucleus, the binding energy per nucleon will decreases. That is also we can say wrong. So option D is the correct option here. If both the assertion and reason are false, both are false here. Okay.